Day14 of the 30-day data science challenge, and today we're going to be going over advanced joins. This is day 9 for them, and we'll be looking at advanced join techniques to handle more complex data relationships. So what are advanced joins, self-join, full outer join, cross-join, using joins with aggregates, advanced join examples, and practice exercise and summary. So what are advanced joins? Advanced joins build upon basic join concepts by introducing more complex techniques for combining tables. These joins are particularly useful when working with hierarchical, multi-dimensional, or interrelated data sets. So we do have self-join, which is a regular join where a table is joined with itself. This is useful for comparing rows within the same table. So there's an employee hierarchy, and we basically have this employees table with employee ID, name, manager ID. To find employees and their managers, we have select e1.name, so that's Alice, Bob, Charlie as employee, and e2.name as manager. So not sure what the E2 one is, but it's trying to do from employees E1 left join employees E2 on E1.manager ID is equals to E2.manager ID. And then it gives us this table with employee, which is this, and then manager, which I guess it's kind of strange. It's like Alice is an employee, but she's also a manager, and she's managing Bob. She's managing Charlie, and Bob's managing David. So I'm not really sure what they're trying to do, but this is what self-joins are. It's joining, so when a table is joined with itself, so it's useful for comparing rows within the same table. That's pretty interesting. So we have full outer joins. It basically returns all rows from both tables with null and columns where there's no match. So we have these two tables, customers and orders. And it looks like the primary key is customer ID. So to find all the customers and their orders, we have select c.name o.amount. From customers C, you have the full outer join orders O, and then you go from on c.customer ID to o.customer ID. And we get this result, and you can notice there are some null values. We also have a cross join, which returns the Cartesian product of two tables. Every row in the first table is combined with every row in the second table. We have the products table and we have the colors table. And we probably join with the IDs for product or color. So it's in select p.product name, c.color name from products, and cross join with colors. So now we have the product name matched with the color name. That's pretty interesting. Okay. Then we have using joins with aggregates. So joins can be combined with aggregate functions to summarize data across multiple tables. We have the total sales by customer. So we have the orders and we have the customers table. And then to calculate the total sales by customer, you can select c.name sum o.amount as total sales from customers C join orders O. And on c.customer ID is equal to o.customer ID. You group by C name, and you get this result. And then there's advanced joins, if they're joining more than two tables. So select o.order underscore ID c.name as customer name p.product name from orders O. Join customer C on o.customer ID is equal to c.customer ID. Join products P on o.product ID is equal to p.product ID. And you have conditional joins. So select star from orders O. Left join customer C on o.customer ID is equal to c.customer ID. And then you have c.name like S with the percentage. And there's practice exercises, write queries using self-joins to find pairs of employees who share the same manager. Use a full outer join to list all the products in their orders, including products without orders. Write a cross-join query to generate all possible pairs of customers and regions from a customer and region table. Combine joins with aggregates to calculate average order amounts for each product. Write a query joining three tables to find detailed order summaries, customer name, product name, and total amount. And then we learned about self-joins, which is joining a table with itself. Full outer joins, which is returning all rows from both tables. Cross joins, which is generating Cartesian projects. And combining joins with aggregate functions. And then we'll go over subqueries. Let's go over subqueries now. So this is day 10 of their challenge. This is a powerful way to nest one query within another. Subqueries are essential for writing advanced and efficient SQL queries. Let's go over their syntax types and use cases. So what is a subquery? Types of subqueries, subquery syntax, examples of subqueries versus joins. And we have practice exercises and summary. So what is a subquery? So subquery is a query nested inside another SQL query. They can be used in select, from, or where clauses. They provide intermediate results for the main query. They also make complex queries easier to read and maintain. So there's different types of subqueries. So they're categorized based on their usage and output. We have single row subqueries, which returns one row with one column. Multi-row subqueries, which return multiple rows with one column. Multi-column subqueries, which return multiple rows with multiple columns. Correlated subqueries, which depend on the outer query for their execution. non-correlated subqueries which execute independently of the other outer query. And this is what the syntax looks like. So you have column 1, column 2 from the table name, and then column 3, which is selecting aggregate function, column 4 from table name where there's a condition. So they're enclosed in parentheses. They can use aggregate functions like sum, count, and average. Their placement depends on the clause, select from, and where. And then you have examples. So you have subquery in the where clause, find employees who earn more than the average salary. You have select employee name, salary from employees where salary is greater than, select average salary from employees. And you get this result. So then you have subquery in the select clause. Find each employee's salary and the average salary of the department. Select employee name, salary, and now it's in parentheses. Select average salary from employees E2, where E1 department is equal to E2 department ID as the average department salary from employees E1. So it gives us this result. Then we have example 3 of a subquery. The from clause, so find the department with the highest total salary, select department name, total salary, from select department ID, sum salaries, total salary, from employees, group by this department ID as department totals, then where the total salary is equal to select max of total salary, from select department ID, sum salary is total salary from employees, and group by the department ID. And then we have this result. And then we have correlated subqueries. So find employees whose salary is above the average salary of the department. Select employee name, salary from employees E1, where salary, select average salary from employees E2, where E1 department ID is equal to E2 department ID, and it gives us this result. Then we have subqueries versus joins. So we have, you can use subqueries for nesting one query inside another. Joins combine data from multiple tables. Subqueries performances might be slower for larger data sets. For joins might be faster with proper indexing. For subquery readability, it's easier for complex logic. For joins, clearer for direct table relationships. Then we have some practice exercises, which is writing a query to find the highest paid employee in each department using subqueries. Use subquery to identify customers who place more orders than the average number of orders. Find the name and salary of employees whose salary is greater than the department's average salary. Create a query to determine which products have a price higher than the average product price. And writing a query to find all orders with a total value greater than the average order value. So today we went over different types of subqueries and their use cases, writing subqueries and select from and where clauses, distinction between subqueries and joins, and this is a key component of advanced SQL, and then mastering them will help greatly increase querying skills. And then in the next, video, we'll go over set operations. Thanks for listening.